Hey guys, this is Malinki. Welcome back to my channel, Voice of Malinki. Today we will talk about chemical bonds. And if you are new in my channel, please subscribe my channel. And if you like my video, please do like, comment and share my video. So basically a chemical bond is the association of atoms or ions to form molecules. So this bond is present between two or more atoms or two or more ions to form a molecule. And this chemical bond formation is an exothermic process. Exothermic process is basically a process where energy gets released. And there are different types of chemical bonds such as ionic bond, covalent bond, hydrogen bond, coordinate bond, van der Waals forces, hydrophobic force, etc. So we will talk about them one by one. First one is ionic bond. So this ionic bond is also known as electrovalent bond or electrostatic bond. This bond is formed between oppositely charged ions. That means one positively charged and one negatively charged atoms or ions are connected by this type of bond. Ionic bonds form when one atom transfers electrons to another to become stable. The atom that loses electrons becomes positively charged and the atom that gains electrons becomes negatively charged. So we will see this example. So here we have sodium chloride molecule, and in sodium chloride molecule two atoms are there, sodium and chlorine. Now sodium atom has how many electrons? 11 electrons. And chlorine atom has how many electrons? 17 electrons. So what will be the electronic configuration of sodium and chlorine? So the first shell of sodium atom contains 2 electrons. Second shell of sodium contains 8 electrons. And the last shell of sodium contains 1 electron. Similarly, the first shell of chlorine atom contains 2 electrons. The second shell of chlorine atom contains 8 electrons and the last shell of chlorine atom contains 7 electrons. That means the last shell of sodium and the last shell of chlorine, they are not stable. Okay, to get stable, they should have 8 electrons or 0. So what they will do, the sodium atom will lose 1 electron from the third shell and now it becomes 2 and 8, that means positively charged ion since it lost 1 electron and now it has only 10 electrons. And chlorine atom will take that electron that is released from sodium and chlorine atom will become negatively charged by taking the extra electron from sodium, and the third shell of chlorine has now 8 electrons and both sodium and chlorine, they are now stable and they will form sodium chloride. Next is covalent bond. So covalent bond is formed by the equal sharing of electrons from both participating atoms, and this is the strongest bond in chemistry. The amount of energy required to break a single covalent bond is between 150 to 400 kilojoule per mole. There are 3 types of covalent bonds: single covalent bond, double covalent bond and triple covalent bond. Single covalent bond, when 2 atoms share 1 electron pair. For example, hydrogen molecule. So one hydrogen molecule has 2 hydrogen atoms, and each hydrogen atom contains 1 electron. Okay, so 2 electrons from 2 hydrogen atoms are getting shared, and they will form 1 hydrogen molecule. Double covalent bond. When 2 atoms share 2 electron pairs, for example, CO2, carbon dioxide. In CO2, there are 3 atoms, 1 carbon and 2 oxygen atoms. So, what is the electron number of carbon? It is 6. And what is the electron number of oxygen? That is 8. So, carbon has 6 electrons. That means the first shell of carbon has 2 electrons and the second shell of carbon has 4 electrons. So, here you can see the carbon has 4 electrons. Red one, 1, 2, 3, 4. 4 electrons in the second shell. And oxygen has 8 electrons. That means the first shell of oxygen atom will have 2 electrons and second shell of oxygen will have 6 electrons. So here in this oxygen, the second shell contains 6 electrons, 1, 2, 3, 4, 5, 6. Just like that, another oxygen atom will have 6 electrons in the second shell, 1, 2, 3, 4, 5, 6. Now, this oxygen atom wants 2 more electrons to get stabilized. Same, this oxygen also wants 2 more electrons in the second shell to get stabilized. So, this oxygen atom will get 2 electrons from carbon. This oxygen atom will get 2 red electrons from carbon, and they both are now stabilized. And this carbon atom, which has 4 electrons in the second shell, require 4 more electrons to get stabilized. So, it will take 2 electrons from this oxygen and 2 electrons from this oxygen. So, now the carbon atom has 8 electrons in the second shell and it is also getting stabilized. So, in this way, the CO2 molecule is formed. Triple covalent bond when 2 atoms share 3 electrons. So, here 3 electron pairs are shared. Just for example, you can see nitrogen. Nitrogen molecule contains 2 nitrogen atoms and the nitrogen atom contains 7 electrons. That means the electronic configuration will be 2 and 5. So, first shell will have 2 electrons and second shell will have 5 electrons. So, this nitrogen has 1, 2, 3, 4, 5 electrons, and this nitrogen also has 1, 2, 3, 4, 5 electrons. Now, to get stabilized, both of them require 8 electrons in the second shell. So, this nitrogen will get 3 electrons from this nitrogen and this nitrogen will get 3 electrons from this nitrogen. So, 3 electron pairs are basically shared over here. Okay, next type of bond is hydrogen bond. This bond is formed between hydrogen atom and an electronegative atom. So, here the hydrogen bond is found between water molecules. So, in water, oxygen is the electronegative atom and the hydrogen bond is formed between hydrogen and the electronegative oxygen atom. Next is coordinate bond. This bond is also known as dative bond or dipolar bond or coordinate covalent bond. This bond in which both shared electrons are donated by one atom but shared by both. We will see how it occurs. So, atoms donating electron pair is known as donor and atom which is accepting the electron pair is known as acceptor. So, here we have the donor. It is the nitrogen and it is associated with 3 more hydrogen atoms. So, nitrogen has 5 electrons in the second shell. So, these green 1, 2, 3, 4, 5, these 5 electrons are there in the second shell and each hydrogen atom has one this red electron. So each hydrogen atom has one electron in its shell. Now what happens? The hydrogen atom requires one more electron in its shell to get stabilized, and the nitrogen atom requires 3 more electrons in its second shell to get stabilized. So in this way it is arranged. Now this is one more hydrogen. It has a positive charge. That means this hydrogen lost one electron. So what happens? It comes here. So this hydrogen is the acceptor. It accepts the electron from this green one. This one is getting donated to the hydrogen atom from this NH3, and now the whole complex is NH4 plus, that is the ammonium ion. Last one is van der Waals force. So it is an attractive force which is formed when two atoms are closely situated due to the fluctuations in the charge density of particles. An atom is polarized with positive charges at one end and negative charges at the other end, which creates an attraction between neighboring atoms. And this van der Waals force is the weakest bond. So in this picture you can see this is atom 1, this is atom 2. Now what happens? This plus, this one is the nucleus. Here also this one is the nucleus. And these minus are negatively charged electrons. Now what happens when these atoms are close together? What happens? There is the attraction between positively charged nucleus and negatively charged electrons. So what happens? The positively charged nucleus in the atom 1 is shifted towards the left, and the negatively charged electrons are accumulated over here in the right, so that there is the attraction with this atom 2. In atom 2, the positively charged nucleus is shifted toward this left, and negatively charged electrons are accumulated in right. So there is the attraction between the positively charged nucleus of atom 2 and negatively charged electrons from atom 1. So this is the bond that is called van der Waals force. This is basically a force. So in this way the atoms are polarized and they attract one another. But this is very weak bond or very weak force, and this decreases with increasing distance. So once these atoms are getting separated, the force becomes very poor. It is very weak. Okay, so this is all about today's lecture. I hope you liked the lecture. Thank you for watching my video.